Dear students, in this video I would like to explain the importance of logarithm tables. In physics and mathematics, usually we have a problem to solve a big fractions and long multiplications. In this occasion, if you use logarithm tables, we can find the exact accurate value of the big fractions, even though that fractions contains digits. So, how to use logarithm tables? Very interesting topic, isn't it? So, first of all, I would like to show you what is the logarithm book. This is logarithm book. So, here is a physical, chemical, and mathematical tables. In this book, the first page is logarithms, and the second page is also logarithms, and third and fourth page anti-logarithms. The remaining pages you can find trigonometric ratios, sin 24, sin 30, whatever degree. You can easily find the sin, tan, cot, trigonometric ratio values also. So how to use this logarithm tables? Let me explain. How to use logarithms. First of all, I want to take a formula, Newton's universal law of gravitation. This Newton's universal law of gravitation, what is the formula for this? F is equal to G capital M into small m by r squared. Do you know this formula? Here G equal to universal gravitational constant. The value of G is 6.673 into 10 power minus 11 Newton meter square kg power minus 2. And M is mass of Earth. So mass of Earth is 6 into, suppose M value 6 into 10 power 24 kgs. M is equal to G mm by r square. This is the mass of Earth, 6 into 10 power 24 kgs. So here mass of the body. Suppose mass of the body is 1 kg. Mass of the body, let's say 1 kg. And r is equal to radius of Earth. Radius of Earth are equal to 6.4 into 10 power 6 meters. If you substitute this value in the above formula, we get F is equal to, F means the attraction force between the Earth and the object. So G value, substitute G value, we get 6.673 into 10 power minus 11, and M value 6 into 10 power 24, and the small m, mass of the body, M is 1 divided by, here r square is there, r value 6.4 into 10 power 6, so 6.4 into 10 power 6 into 6.4 into 10 power 6. You understand this is a big fraction. Why I am explaining this, how to use logarithms in this calculation of last step here, f is equal to 6.673 into 6 divided by 6.4 into 6.4 into 10 power minus 11 into 10 power minus 24 into 10 power minus 12. 10 power 6, 10 power 6, 10 power 12. If you get that value to the numerator, it will become 10 power minus 2. Here is the fraction 6.673 into 6 divided by 6.4 into 6.4. We need to find the exact value of this fraction. So how can we find? It can't cancel, it is not easy to cancel. So we go through to find the value of this fraction with the use of logarithm tables. So let me start the logarithm tables. How to use the logarithm tables here? So first of all, 6.673 into 6 divided by 6.4 into 6.4. Actually, in the numerator we have two values, in denominator also two values. Before going to calculate this fraction, log a by b is equal to log a minus log b. This is the one formula you have to understand. And log ab is equal to log a plus log b. So we use these two formulas to calculate this fraction. So first of all, what we have here, log of 6.673. So we need to find log of 6.673 and 6 log 6. So both logarithms here, log a into b. It is a form of in the form of log a into b. So log a log b. Log a into b, log a plus log b. So both these two logarithms will be added. After that, log of 6.4 is equal to and log of 6.4 right here. So in the denominator, so we used to add these two values also, because in the denominator also log a into b, in the form of log a into b, we use this formula. So both these values to be added. After this is the numerator value, this is the denominator value. Both values log a by b, we use this formula. So first of all, how you have to find out these values? Let me go through the logarithm tables. First of all, log of 6.673. If you want to find the logarithm, we need at least 3 numbers. Here 4 numbers, 1, 2, 6, sorry 1, 2, 3, 4 numbers are there. So first of all, there is a point here. Before the point, you have only one digit. The characteristic is 0.0 point. The characteristic. So here only one digit is there. The characteristic is also 0 point. So here before the point only one digit. The characteristic is 0 point. Here also the characteristic is 0 point. This is the characteristic. So we need to lower the one number to get the characteristic. Suppose if you have 3 numbers, the characteristic is 2. Suppose if you have 4 numbers, the characteristic is 3. Here point is there. If you don't have the point, the characteristic is 3. But here is the point. So therefore, we have to calculate the numbers before the point. Before the point, we have only one digit. So therefore, the characteristic is 0 point. So now take the logarithm table. 6.673. So we already put the characteristic value. So no need to take the point into consideration. So 66, 7 main difference thing. Okay, 66, 7. Here 66. So here 66. 66. So here we have to logarithm table 66. 7. So what is the value of 66, 7? 8241. 8241. In the mean difference we have 3. Under the t we have 2. So 66, 7. 66, 7. 6370 and add 2. 6372. So 6372. That is the value of logarithm of 66, 7, mean difference 3. So 6372. Next, here only one digit. logarithm. Here, remaining 2 digits we assume as a zeros. So 60 0. So find out the logarithm of 60 0. 60 0. 7 7 7 7 8 2. So 7 7 8 2. So we have to add these two numbers. So 2 to 4. Here 7 8 15 1. So 11 1. So 6 7 7 14 1 1 9 4 1 5 4. Again here 6.4. So already characteristic is 0 point. So 64 0. So what is the 64 0? 64 0 in logarithm table. So we have 8062. So 8062. Again this is also same value. So 8062. Add these two numbers. 4 here 12 1 1 16 1. So 1.6124. This is the numerator value. This is the denominator value. Both these values to be subtracted. So 1.4154. Here 1.6124. 6124. So subtract these two values. So 4 minus 4 0. 5 minus 2 3. 1 minus 1 0. 4 6. So here if you subtract 4 to 6 or 14 6. If you subtract from 14 to 6 8 0. The value is 0. 0 minus 1 1 bar. So 1 bar 0.8030. 1 bar 0.8030. So here we have to take after this final step anti-logarithms. So anti-logarithm of 1 bar 0.8030. 8030. 0 minus 1 actually. So we put 1 bar, okay? So 1 bar 0.8030. Anti-logarithm always calculate digits after point. So here the anti-logarithms, in the anti-logarithms 0.8030, 0.803. So we have to calculate 0.803. So 0.803. So 0.803 here we have 6353. So 6353. So now we have 1 bar point. What is the point in this number? So if you have 1 bar point, we have to put 0 point. So this value is 0.6353. 0.6353. So here 10 power minus 11 minus 12. Minus 11 minus 12 minus 23. So minus 23 into 10 power 24 and 10. So minus 23 24. That is only 1 plus 1. So 10 power 1. So if you multiply this one, we have 6.353. 6.353. 6.353. So first of all, we want to take logarithms. Then at final step, we need to take anti-logarithms. Okay? Now, how can you put in this kind of characteristics? So this characteristic value. Suppose if you have log of 243, the characteristic is 2 point. So we need to take the value of 24, 3, okay? Log of 24, the characteristic is 1 point, okay? Log of 2, the characteristic is 0 point. Suppose if you have log of 1.43, this is also 0 point. Suppose log of 0.43, this is 1 bar point. So these are all characteristics. So if you have 3 digits, the characteristic is 2. If you have 2 digits, the characteristic is 1 point. If you have only 1 digit, the characteristic is 0 point. If you have point in the value, then before point you have only 1 digit, so it is 0 point. So if you have point and also there is no value before the point, so 1 bar point. Okay. Suppose if you have 2430, What is the characteristic? We have 4 numbers 1, 2, 3, 4. The characteristic is 3, 5. In all these values 24, 3 in logarithm tables, we need to take a value of 24. So in the first row we have from 10. So logarithms are always calculated base 10. So 10, 11, 12. So logarithm starts from 10. So 24 in the column, and next in the logarithm tables, so in the bottom we have 0, 1, 2, 3, 4, 5 up to 9. So 24 in the first column and 3. This value have to be taken here. 24, 3. Okay, 24, 3. If you have 7 here, 24, 3, mean difference 7. So again we have mean difference. Mean difference in the table is the last here in the mean difference. So 24, 3 in the logarithm table, then mean difference 7. Add that value to this one. Okay. So now anti-logarithms. How can you put the point in the anti-logarithm? Suppose if you have anti-log of 0.143. Suppose if we have the value of 2463, 0 point means we have to put after one digit 2.463. So anti-log of 1.143, again we have the value of 2463. So 1 point here, so we have to put the point after 2 digits. Suppose anti-log of 2.143, so again we have 2463. In this all cases 14.3, we have to 0.143, we have to take the value of in the anti-logarithms 0.143. So 0.143, 2463, again here 2463, here also 2463, but point here 2.460, here 24.60, here 2 points are there, so therefore we need to put the point after 3 digits to 246.3. So here again anti-log of suppose we have 1 bar 0.143, 1 bar 0.143. Again anti-logarithm value for 14.3 is 2463, but 1 bar is there, so 0.2463. 0 point, if we have 1 bar, we need to put 0 point. Suppose anti-log of 2 bar 0.143, so 2463, 0.02463, 0.02463, anti-log of 2 bar 0.143, that value. So this is the way to find the anti-logarithms.